Probability, random variables, a form of probability distribution where you'll be required to calculate the expected value as well as the standard deviation. Now, this happens to be the easiest probability distribution where you need to know three cardinal issues. Number one, that the expected value is the mean. Sometimes it's denoted by the letter E and a small x. This is the expected value. Then the variance, which is summation of x squared px minus summation of x px all squared. Then standard deviation, as usual, is whenever we square root it, and that we square root the variance. So I have two questions we're going to look at. Question number one, I will do. Question number two, I'll ask you to try. Then we'll refer this to what we have in the assignment. So to calculate, the easiest of them here is the last part, probability greater than or equal to 3. It means you're starting from what? Probability of 3 going upwards. So 3 plus probability of 4. So probability of 3 plus probability of 4. These are the numbers greater or equal to 3. Probability of 3 is 0.4. Probability of 4 is 0.3. When we add this, we get 0.7. So this is a probability of x is greater than or equal to 3. They will also tell you to find probability at most 3. At most 3 is 3 and below. So you're going to look at 0.2, 0.1, and 0.4, which gives you 0.7 as well. But if they ask you to find greater than 3, it is only 4, which is greater than 3. So the probability will be at 0.3. Is that clear? So to calculate the expected value for the x values of 1, 2, 3, and 4, with the respective probability, we have 0.2, 0.1, 0.4, and 0.3. Multiplying the probability and the values of x will give us our mean. So x times px, we're going to multiply 1 times 0.2 is 0.2. 2 times 0.1 is 2.2. 3 times 0.4 is 1.2. And 4 times 0.3 is also 1.2. So when we add this, we're going to get 3.8. This is called our mean of the expected value. So our mean here is what? 3.8. Then we're going to square the values of x. So this is 1, 4, 9, and 16. We're going to multiply them by the probabilities, which will be x squared times px. So here, this by that, we get 0.2. 4 times 0.1, we're going to get 0.4. 9 times 0.4, we're going to get 3.6. And 16 times 0.3, we're going to get 4.8. So adding these ones here, we're going to get 0.32, 9.0. So when we add this, I repeat, we're given these two figures here. 1 times 0.2, we get 0.2. 2 times 0.1, we get 0.2. 3 times 0.4, we get 1.2. and 4 times 0.3, we get 1.2. So when we add all this, 0.2
2.8.
get 2.8.
Yes.
Okay, so this is 2.8. And we sum total. So this is our mean. When we go to the variance, we subtract the variance, the x squared px time minus the mean. So 2.8 to the power 2, we subtract it from the mean. So this is 9 minus 2.8 squared. What do we get?
6.2.
9 minus 2.8 squared. Try again.
One point one six.
0.16.
1.16.
Then when you square root it, it is called the standard deviation. So 1.16 square root, what do we get?
1.08.
1.08. So I'll ask you to do question 2 within 10 minutes. Question 2 within 10 minutes. I'll ask you to do it quickly so that we go to the assignment question. The output will ultimately come like this. So we have values of x and their respective probabilities. Multiplying the values of x by their respective probabilities will give us xpx, which totals to 4.2. This is called our expected value or expectation or mean. When we square the values of x here, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 16, up to 6 times 6, which is 36. Thereafter, we multiply this by the respective probabilities, 1.8, 4.8, 5.0, and 7.02. What we get is summation of x squared px. This is not the variance, but when you subtract the variance minus the square of the mean, we get the variance. Summation of x squared px minus the mean squared, we get the variance. Square rooting the variance gives us our standard deviation. So if we are told greater than or equal to 3, is that from 3 up to 6, the last number. So this is one of the easiest probability distributions. Then it is very close to what is called regression analysis. Regression is mainly used to ascertain the relationship that exists between the dependent variables and the independent variables. So the regression equation is given by y is equal to a plus bx. So which of these two variables is dependent on the other? Which one is independent and which one is dependent? Y is what?
It's
Dependent
dependent.
on x. Okay. How do we know y is dependent on x? It changes as you change the values of x. But whether you change values of y, x doesn't depend on y. So this is what? Independent. So the regression equation can have a positive slope or it can have a negative slope. Like B stands for the slope, which is the gradient. A stands for the y-intercept, where it's cutting the y, because this is the y-axis, and this is what? The x-axis here. If there's no relationship at all, the line will be like this, meaning our B is 0, our gradient is 0, or our R is 0. So there are key terms that we're going to look at. What did I say is A? A is what?
Gradient.
Gradient. It's y-intercept. And what is B? The gradient or the slope. Are we together?
No.
We're talking about the regression equation, which is given by y is equal to a plus bx. This is called the regression equation. A is called the y-intercept, where it's cutting the y-axis. B is called the slope, the gradient. This one is given by y is equal to a minus bx. The difference between the two is that this one has a positive slope and this one has a negative slope. This one has no slope at all, just 0. So there's no relationship between x and y. Now there's a variable called R, which stands for the coefficient correlation. Coefficient correlation. It tells you whether the relationship is positive or negative. It's called R. So if you have a positive relationship, your slope will also be positive. If you have a negative relationship, your slope will also be negative. And when you square that answer, it's called coefficient of determination. Coefficient of determination. So it tells you how much of y depends on x. It gives you the variation percentage. Examples of two variables that depend on each other are sales and advertising. Sales depends on advertising. Give me any other two examples you know that have dependent on independent variables. Any two? Hours of study and mark performance. The more you study, it's assumed that the higher you do what? You get good grades. So these relationships exist. So we'll be given an example, X and Y. 1, 2, 3, 4, 5. And for instance, here we have 1, 1, 2, 2, and maybe say 4. All right, so you'll be asked, how is the relationship between X and Y? Let's see whether it's a positive or a negative relationship. If one variable is increasing and the other variable is decreasing, you know that is a negative relationship. An example is demand. If both are increasing, that is what? Supply, it's a positive relationship. You're able to tell. 1, 2, 3, 4, 5. So this is 1,1, you put it here. 2,1, 2, start with x, y. 3,2, 3, 2. 4,2, 4, 2. And 5,4, 5, and 4. So this is your y, and this is your x. What can you tell me about this? It has a positive relationship because you can see it's upsloping. The strength, you can't tell so much, but it seems to be strong. They are close to each other. When the dots are apart, are far from each other, it's a weak relationship. So R shows you whether it's positive or negative. So here R is positive. R squared shows you the strength. So now we want to come up with a regression. Try to fill in this xy, x squared, and y squared, and get the totals. I'll give you a few minutes. So if you carefully do your computations, you will find the values of x, y, and the total as 37, x squared, and the total as 55, y squared, and the total as 26. These are the summary totals. Our n is 5, which represents a number of pairs. So this is a regression equation. We need to find A and B. So we start with finding B. Having gotten the summary totals, our B will be n xy minus summation of x times y over n x squared minus ax to the power 2. So we substitute the figures as they are. We'll find our B, which is our slope, as 0.7. Please note that if your B is a positive, your R will obviously be a positive too. So the formula for the R, which is the coefficient of correlation, is given below. Answer will be 0.903. When you square it, it gives you our R squared, which represents the strength. 81.7% of Y is affected by X. This is what it means. So our summary, Y is equal to A plus BX. I hope you are following even in my mute state so that you can see what is happening. R was 0.903. We're interested in the sign. This means that X and Y are positively related. They are directly related. R squared was 0.817, which means 81.7% of Y is affected by X. Okay. Affected by X. For your homework, you capture this. In fact, sometimes the examiner want to swap X and Y. So I'll start with Y and X here. So we have 10, 8, 6, 4, 2, 1, 4, have 1, 4, 4, 7, and 8. So I want you to find 1, plot the diagram. 2, find Y on X, meaning find the regression equation. Number 3, find Y if X is 10. Find Y at X equal to 15. Then R and R squared and comment. Can capture that. Okay, so we will end here.